So I would graph it first, obviously, because then you have something to look at. This is absolute value. So what shape is it going to be? It'll be a V shape. And what's been done to it? Good. Left 6. So start out with that. From the origin, you're going to go left 6. And you can make a table. That is always valid. But for absolute value, what's kind of easier, and I'm just trying to save you work, is you can use that number out front as your slope, that -1/3, and just go down 1/3 in each direction. And then just keep going down 1/3 for like a little farther so you can see where it's headed. So it's widened out, it moved left 6, it's upside down, and we're just going to use that to answer all these. Now, you know the answers to these. The only thing that ever messes people up is the notation. It's how to write stuff, the brackets and the parentheses, and the order in which you put stuff. I know you know the answers. You just have to be careful with like the little picky mathematical things, okay? So domain, you're going to go left to right. Does it go left forever and right forever? You got everything? Okay, so how do we write that then? Good. Negative infinity, positive infinity. Those get parentheses because infinity is not a number. You can't bracket that. Range, you go downwards to upwards. So it's going to be negative infinity up to what y number? 0. Good. So negative infinity to 0. And 0 will get a bracket because there's actually a point there. And again, that's the only thing that really trips people up, because I know you know the answers. It's just how you write them that can be hard sometimes. All right, x-intercepts. There could be more than one, but in this case, there is actually only one. -6, 0. What's our y-intercept? 0, -2. Good, kind of just look at it. Increasing, decreasing. If it helps you, label the left end negative infinity and the right end positive infinity on your x-axis. I mean, it's not a requirement. I'm just saying, hey, it's helpful. What is the graph doing first as you go left to right? Good. Increasing. So increasing is negative infinity until where? -6. Good. And then decreasing is -6 to infinity. Good. And for that one, I don't care about the brackets or parentheses. You can't bracket an infinity. But other than that, the only one that's picky about it is domain and range. Here, you can put whatever you want there. We're only going to have one or the other of these. Do we have a maximum or do we have a minimum? Yeah, maximum. This is going up and then going down. So we will not have a minimum. You could put none or NA or whatever you want to put there. Now it's the points -6, 0, but we write it the other way around. So it's 0 at x equals -6. And then end behaviors. You guys did really well with the notation of this. It's LIM for limit x goes to negative infinity for the function. Limit x goes to positive infinity for the function. The only thing that really gets people on this is they'll leave it blank. And I get why that happens. They set it up and then go, oh, I'll come back and answer that, and then forget to. And when they go and look over their test, the line is filled in so they feel like they answered it. I try to catch those as people turn them in and give them back, but I can't catch everything. So, you know, try really hard to remember to answer it. Where is the left arrow pointing? Down, so we're going to say negative infinity. This one is also down, so also negative infinity. Cool so far? Hanging in there? That was not too bad. Once you get the graph, usually you're good to go. All right. What is this parent function? Rational. And how did it shift? The down 3 is good, so we're going to go down 3 and dot that in. And then what else? Left 2. So go left 2 and dot that in. It's like the entire axis moved. And I don't need specific points. As long as those are dotted in, we're good. And then you can just draw your graph. Some people will use a highlighter for those. I kind of like when people do that too, because it's technically invisible. So actually, let me go ahead and answer the vertical and horizontal asymptotes first, because we just dotted them in. Where's the vertical one? Yeah, and you have to get whether it's x equals or y equals. It's your Hoy Vux. So vertical is going to be x equals good. And we said that was at -2. And then what would horizontal be? Look at the horizontal one. Good. Y equals -3. So maybe just do those first because you have to dot them in first anyway. So let's do our domain. Just watch me point to it. We're scanning left to right. It goes left forever and right forever. Who is not invited to the domain party? Who got left out as we scan? -2 is not invited. They're a troublemaker. Kick them out. Do you remember how to write that? We want to everybody except -2. I'll give you a hint. It starts with a negative infinity. To -2 with a parentheses. Good. Oh, whoops. Union, that's like, hey, wait, we're not done yet. Good. Oops. -2 to infinity. So what you're saying is you want everything to the left of -2, everything to the right of -2, but not -2. You're leaving that out. So no brackets should be in that because you're excluding it. You're saying leave it out. Range is going to get written the same way, except you're going downwards to upwards. So who is not invited to the range party? Who got left out? -3. Do you see how that's the one that's getting left out? You're seeing this here? All right. So you're going to write it the exact same way, but leave out -3. I'm going to come back to the intercepts because those are going to be a little bit tougher. Okay, so I'm going to skip those for just a second. Increasing, decreasing. Hey, watch me point to it, guys. What is the graph doing as I trace left to right? All right, decreasing. Even on this side, as we go left to right, it is decreasing. Is it ever increasing? No, so that's none. And if it decreases all the time, you just copy over the domain. It's decreasing everywhere except at that -2 that we had to leave out. So you're just going to copy over that domain answer. All right, and then go ahead and set up your limits for your end behavior. Limit x goes to -infinity of the function. Limit x goes to +infinity of the function. And then just watch me point to it. This left arrow is leveling off at what number? -3. And this right arrow is leveling off at -3. It's never going to actually touch -3, but that's where it's headed, and it's just behavior. So you just put whatever that number is. Hey, Ms. Cole, is it always going to be the horizontal asymptote? Yes, it will be the same number. Whatever you get right here, these two are going to match. All right, let's go back and get the intercepts because those are a little tougher. Let's do the y-intercept first. It's going to be 0 something. You just plug in 0. This is that fun with fractions. We did one like this and it went well because you guys have good algebra skills, but you just can't be scared of the fractions. Ready? 0 plus 2. 2. So you have 1/2 minus 3. I'm just going to write that over here. 1/2 minus 3. And you need a common denominator. So here's the million-dollar question. How many halves is 3? Good. How'd you get 6? Because that's correct. Just smart like that. 2 times 3 is 6. Or you could think 6 divided by 2 is 3. However your brain does that. And then 1/2 minus 6 halves is -5 halves. So -5 halves is what we got done. Now, when we go to do the x-intercept, it's going to be something 0. You have to take the entire equation and set it equal to 0. So you're going to take this whole thing and make it equal 0. So I'm going to copy over the function and set it equal to 0. Again, we did one like this earlier this unit, and I was really impressed with you guys. It went well. What's our first step? You just want to start solving. We're going to do it. Add the 3 over. Good. 1 over x plus 2 equals 3. Just do plus, if you want to write plus 3 to both sides. I generally don't do that once we get to pre-calc. I expect you to be able to see the steps, but write it in if you need to. All right, then what? You're multiplying the x plus 2 to the other side. Watch. Don't look away or you're going to miss it. The fastest way to do that is cross it out and write x plus 2 on the other side. Trying to save you some work. Do you remember me doing that? Cross it out, just write it on the other side. All right, now what are you going to do with the 3? Distribute 3x plus 6. And then subtract 6. 1 minus 6. -5. I ran out of space, but what's your last step? Divide by 3. So -5 over 3. It's just solving an equation. But you can't do it without writing stuff down. You don't do that in your head. You have to do work. I'm sorry. There's work. I'm so sorry. Work and stuff. We'll do one more of the graphs and then we'll do our break there because that's like probably about halfway. All right. Square root, it's going to be like this. How did it get shifted? Down 5 and right 1. From the origin, you're going to go down 5 and then right 1. And then I'm going to make a table and try and find some other numbers to plug in. We get something that doesn't work, we will pick something else. But we started at 1, like we're centered at 1. So maybe pick something next to 1. Just throwing that out there. Next to 1. Let's pick something next to 1, like 2. 2 minus 1. 2 minus 1 is 1. Good, but it's negative. You can't square root a negative, so let's try something else. Let's pick something next to 1. Thank you. Thank you. 0 minus 1. -1, but it's -1, so it's +1. Very good. Square root of 1 is 1 minus 5 is -4. So 0, -4. And then, yes, I will do -3. But you can't skip that one because you need the y-intercept. So you can't go around skipping stuff, all right? -3 minus 1. -4, but it's going to be +4. Square root of 4, 2. And then 2 minus 5 is -3. So -3, -3. All right, domain. You're going to go left to right. Watch me point to it. You want everything on this side up until what x number? 1. So it's going to be -infinity to 1 with a bracket because there's actually a point. Make your brackets really brackety. Range, you're going to go downwards to upwards. There's nothing down here. What y number do you start at? All right, good. -5, oh, with a bracket. And then I know it's not in a great big hurry, but do you see how this is going to keep on going up forever and ever? -5 to infinity. That's not a very good bracket. Let me fix that. I was just saying make your brackets look really nice. Let me make that look better. X-intercept, that's a little tricky. If we look at this, it kind of looks like there isn't one, but isn't this going to keep going and like eventually run into the x-axis? Okay, so there's going to be an answer. We're going to have to like do work, okay? Or I guess what you could do if you didn't want to work it out, you could sit there and try numbers until you got it. Do you want to do guess and check or do you want to work out all the steps? You want to try and guess? -24? Negative 24 minus 1. Negative 25, but it'll be 25. Square root of 25 is 5, and then 5 minus 5 is 0. Really good. You worked it out. Let me work it out and just show everybody. I'm just saying you can't just guess if this bothers you to work it out, but just watch. Just watch. Okay? I'm going to take a picture of this and post it. You can always get it later. First step would be add 5. Just watch is all I'm asking you to do. How do you get rid of a square root? Square it. 5 squared, 25. Do you see this negative out front? Watch. Don't look away. This is the easiest way to deal with that. Watch. I'm going to erase it and put it over here. All right. And then plus 1. Negative 25 plus 1, negative 24. All right. Y-intercept. That one we should be able to just look at the graph. 0, comma, negative 4. This you have to read left to right. I know you know what increasing and decreasing means. You walked through that door knowing that. I didn't teach you that. What I'm teaching you is the notation. You have to read left to right. So what is the graph doing if I start on the left side and go right? Decreasing. So it decreases from negative infinity until 1. Good. And I don't care if you put a bracket or a parenthesis on the 1 at that point, it doesn't matter. Why is there only one line for end behavior? There's only one arrow. Which way can we go? Limit x goes to negative infinity. We can only go to the left. There's not a right arrow. And again, I know it's not super dramatic or anything, but where is this arrow pointing? Up. Like it's going to keep going up. So we would say positive infinity. So we're going to use this graph here. Any relative maximums or minimums. So there is one of each. Here's your maximum. But remember how we write it. It's something at x equals something. That one's actually kind of nice. You really can't get it backwards because they're both what? Yeah, 4. So it's going to be 4 at x equals 4 for your relative maximum. And then this one's your relative minimum. How would we write that one? Yep. Good. Negative 9 at x equals, what was it? Negative 2. The only way people mess those up is they'll accidentally write them on the wrong lines. So just be careful. All right. And here we're going to do increasing, decreasing, constant. This one does get people. There's not a constant piece in there. It is increasing throughout that entire time. So these are going to both say none. And what would increasing be? If it increases all the time, negative infinity to positive infinity. To clarify, an exponential would be the same thing. Can you actually draw this one on there? I want to make sure you understand this. You have that asymptote there. You know how an exponential looks like that? There's not a constant bit in there. This is also increasing all the time. It's the exact same as the one we just did. Increasing all the time. If you have an exponential, did that message get delivered? Okay. There's not a constant piece. It increases all the time. All right, this has a constant piece in it, but let's go left to right. We're going to do negative infinity to positive infinity. What does the graph do first? Right. Decrease. So on your decreasing line, just make sure you don't write it on the wrong line. It's going to be from negative infinity until what number? Be careful, you need to use x numbers. 1, good. Because it's left to right. And then constant would be 1 until, what is that, 5? And then increasing 5 to infinity. Again, the only thing that gets messed up there is people accidentally write them on the wrong lines, so just be careful. That usually goes well, though. Okay. Number 7, find A that makes the piecewise function continuous. Hey, guys, if it's continuous, you need the two pieces to do what? Equal each other. They need to meet up. So you're just going to take x plus 5 slap an equal sign in between, and then put the ax squared minus 1. You're just setting them equal. You want them to meet up, then you have to set them equal. And then you're going to plug in what for x? -2. It's going to tell you right there. You're going to plug in -2 everywhere that there is an x. And then it's algebra. You have to just do algebra until you figure it out. So on the left side, that would just be 3. Over here, when you square something, it becomes positive. So +4. So this is 4a minus 1. All right, then what? I don't want to just talk at you. You know how to do algebra. What would be next?
Add 1.
Yeah, add 1. So 3 plus 1. 4 equals 4a. Divide by 4. What do we get? 1. Okay, set them equal, solve it. What happened? It's our math not mathing. All right. Number 8, state the x values where this graph is discontinuous, label it as removable or non-removable. All right, there's a few of them. What have you got? Where is there a discontinuity? X equals what? 0. Is that one removable or non-removable? Since it's actually broken. Non-removable, good. There's a couple more though. There's 2 more. X equals -5, perfect. Is that one removable or non-removable? Removable, you just literally removed a point. And then what's the last one? 4. It's invisible, but if you want to dot it in, there's an asymptote there. So x equals 4. And is that one removable or non-removable? Yeah. Non-removable. You didn't just remove a point, actually like broken. All right, and then we're going to do domain and range. Watch me point to it because it's a visual thing. I don't have a better explanation than, hey, look. As you go left to right, did we lose -5? No, the point is still there. It got put somewhere else, but we still got it. Did we lose 0? No, it's still there. We've got it. So sweeping left to right, we have all of these. Who's the only number not invited to the domain party? 4 got left out. How do we write it? Good. And then union, perfect. Parentheses. Because if you put brackets, you're including it. We don't want to include it. We want to leave it out. 4 got kicked out. All right, and then we're going to go downwards to upwards for the range. So just look, I'll point to it. Going downwards forever. Did we lose -2? Yes, -2 is missing, and the point isn't somewhere else. Okay, so hold on, though, because I think there's another one. Although maybe not. I don't know. Let's see. We lost -2 for sure. Did we lose 0? Well, there's a hole there, but I have this point here for 0, so I didn't lose 0. And then this goes on upwards forever. So actually we got everything else. So -2 is the only number that we lost. If you were like, hey, that was hard. Yeah, those can be tricky. Domain and range can be hard. It's not a simple thing. You got to get practice looking at them. Not super easy. All right, here, you have to make a decision. If you missed this on the quiz, it's like that's what quiz is. It's feedback, and then you can be like, self-assess. Okay, what do I need to fix for next time? If you missed this, fix it for next time. You have to make a decision. Is 0 bigger or smaller than 2 last time you checked? Smaller. So that means you're going to use, bless you, the first piece of the function. If you plug in 0 to that, what do you get back out? 3. Good. That's your answer. Is 1 bigger or smaller than 2? Smaller. So same thing. You're going to use the first one. If you plug in 1 for x to that, what do you get back out? 5. 2 plus 3 is 5. And then how about 2? Which piece does 2 belong in? Yep, the second one. Why? Is equal to. Okay, so this one's a little tougher. I'll talk you through this one. If you plug 2 into that, 2 minus 3, -1, squared is +1. minus 1 is 0. What if I asked you f of 7? Which one would you plug into? The bottom one. F of -3? The top one. Okay, so you just have to make a decision. And then here's where we're going to graph these. This went really well on your quiz. Can you guys like make me proud and do that again? Okay. We're going to plug in 2. But Miss Cole, you can't plug in 2. There's not an equal to. You can, but you're going to put open circle. All right, follow me on this. If you plug in 2, 2 times 2, 4, plus 3, 7. So 2, 7, open circle. And you can make a table. That's never wrong. But if it's a line, I would encourage you to use the slope because it's just less work. I'm just trying to save you work. What's the slope of this line? 2. Do your slope of 2 like that. If you can count to 2, I mean, I'm just trying to save you work. You can always make a table, but I'm just trying to make it easier for you. Because the material is already hard enough. I'm trying to make it simpler for you. Just 2. Count to 2. There's your slope. You can also always graph the entire thing and then just erase the part that you don't want. All right, this one's a parabola. We're going to start by plugging in 2. Oh, wait, we already did, didn't we? When we plugged in 2, what did we get? 0. All right, 2, 0, closed circle. And then I want to plug in some more numbers like we did 2. So let's do like 3, 4, 5. Let's see what we get. Let's do 3, 4, and 5, see what we get. All right. If you plug in 3, 3 minus 3, 0, squared, 0, minus 1. All right. If you plug in 4, that'll give you 1 minus 1. Which is 0. And if you plug in 5, let's see, 5 minus 3 is 2, squared, 4 minus 1, 3. So go ahead and plot those. It should be a U shape. But again, you guys like impressed the heck out of me on that question on your quiz because that's like the hardest one and it was like really good. Like you guys did awesome with that. Graphing is usually what everybody finds the toughest thing. I was super proud of you. All right, last page. You're gonna be okay. All right, we're gonna use this graph right here to answer these questions. Again, this went really well on the quiz too. Just do it again. F of -2. All you're doing is finding the point -2 comma something. It's whatever that something is. So when you find -2 on the graph, what's the output value? -2, -1. Do you see that right there? I'm sorry, I don't have a better explanation than, hey, look, it's this point. -2, -1. All right, -1 is a little tricky. You have to get where the actual point is. So where's the actual filled in point? 4, perfect. And then f of 3 is 4. What would be f of 7? 4. And f of 300 million? 4, because it's constant. It's going to stay 4 forever. All right, and then here we're going to write the equation. Do you remember my suggestion? Do the break in the domain first. I think you guys followed that because again, this one went really well. Where's your cut point? Where does this break? Good. The first piece, you want x less than -1. Just leave like a space. We'll fill that in. And then the other piece, we want it to say x greater than or equal to -1. And do you see how I put the equal to where the filled in circle is? Okay, do that first. Then go back and, write your equations. This is a parabola. How did it shift from the center? How this new center point? Yeah, left. I heard someone say left 3 and then down 2. So it would be x. And then what? To do the left 3, it's kind of backwards. It's +3 squared -2. Good. And then the constant one is the easier one because it's literally just 4. It's like the number 4. That's it. Not even a variable. These last ones are that intermediate value theorem. Hey guys, what does the word intermediate mean? Like if you have beginner and advanced, intermediate means in the middle. And what does the function have to be that you have to mention? Begins with a C. Yeah, continuous. Good. So you have to mention those two things, continuous and in between. So number 11, does this function have a value C, blah, 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 in the interval that equals -2? You're going to have to plug in -2 and see what you get, and plug in 3 and see what you get, and then check if this number is in between them. You're just checking if it's in between. That's what intermediate means, is in between. Okay, so let's plug in -2 and see what happens. -2 squared 4, -2 times -5, 10. So 4 plus 10 is 14. Now let's plug in 3. 3 squared 9, 3 times 5, 15. So 9 minus 15, was that -6? So here's the whole point. Is -2 in between these? Yes. So you're going to say, since f of x is continuous. Oh, and here's what I get all the time. But Ms. Cole, the problem didn't say continuous. I hear you. Do you see how this is squared? What shape is that graph going to be? A U shape. Isn't a U shape continuous? Yes. Okay, so it is. All right. Since the function is continuous, and you have to say in some capacity that -2 is between these. All right. So -6 is the smaller one. That's f of 3. And then 14 is the bigger one. That's f of -2. If you don't like that, if you're like, that bothers me, remember you can write it out in words. You can say -2 is between f of -2 and f of 3. Like you can say is between, like you can write it in words if you like that better, because the symbols do bother some people. But in some capacity, you have to say it's in between. So since f of x is continuous and -2 is between those, there is a value C such that, it's always fun to say such that, it makes you sound like really proper. F of C equals -2. And you're basically just repeating the question. We talked about that too, didn't we? Like in English class, when you go to write the conclusion of your paper, you just repeat the prompt. Did I bring that up? Yeah, like just repeat the question back at itself, okay? Since the function is continuous, 2 is in between, it exists. When I grade these, this is what I'm looking for. Are you ready? This is like what my eyes go to. Did you get 14 or did you get -6? That's the first thing. Okay, good. You got those. Did you say the word continuous? Okay. Did you say this is in between, either in symbols or words? And then did you conclude the whole thing? So like you can play around with how you want to word it, but those are the things I'm looking for. All right, and then here's the last one. Given the values in the table for the continuous function, so it's mentioned, on what intervals? Did we talk about how an interval involves 2 numbers? I'll be like, an interval, and someone's like 5. And I'm like, no, you need another number. On what intervals must there be a 0? What do you think? So 0 is in between a positive and a negative. So this doesn't help you at all because 0 is not positive or negative. You need an interval that 0 is in between. Good, 4 and 5, because 1 is positive and -2 is negative. Was there another one? Oh, that was it. Okay. So on the interval 4 to 5, because f of x is continuous and changes sign. You can be more wordy than that. Like you can do changes from positive to negative or changes from negative to positive, but changes sign is good enough. And again, I'm trying to save you work and make it simpler, but the 0 itself doesn't count because 0 is neither positive nor negative. So you can't use that. Do you understand what I'm saying? Okay, don't use the 0. You need a change in sign and you need to mention continuous.